In section 2.1, we're going to be finding square roots and comparing real numbers. Our learning objectives for this section are finding square roots and comparing real numbers. So key vocabulary you're going to need, or you're going to need to know what a square root is, what is a radicand, what is a perfect square, what defines an irrational number, and what are the different types of real numbers. As we look forward into what a square root is, the definition that they're providing here in the book for a square root is if b squared is equal to a, then b is the square root of a. So for an example, if 3 squared is equal to 9, and if the quantity negative 3 squared is also equal to 9, 3 and negative 3 are square roots of 9. So all positive real numbers have two square roots, a positive square root, which they call the principal square root, and also a negative square root, like 3 and negative 3. A square root is written with a radical symbol, so in radical notation. There are other types of notation, so it can also be written as an exponent, but in this case we're going to be working with radical notation, so you use the radical symbol, and the number or the expression inside the radical symbol is called the radicand. So for here we would read this as the square root of a, and a is the radicand. 0 is an exception, it has only one square root, and its square root is 0. Negative real numbers do not have real square roots because the square root of every real number is either positive or 0. Now, as you continue on in your studies, you're going to find that negative real numbers have square roots that are imaginary square numbers. So they won't be real numbers, they'll be imaginary. So if we want to find square roots, we're really looking for something squared that equals this number. Well, I know that 169 is 13 times 13, right? And if you do a prime factorization and you find two of the factors of the same number, then that number squared is actually a factor, and in this case, the entire factor, so plus or minus 13. You could also look at it as this is plus or minus the square root of 13 squared, which also would end up giving you plus or minus 13. When you think of order of operations, square roots fall in the exponent level of order of operations. And this minus sign falls under the multiplication level because this is the same as negative 1 times the square root of 9. Well, the square root of 9 is going to be plus or minus 3. And negative 1 times positive 3 is negative 3. And negative 1 times negative 3 is positive 3. Typically, though, if you saw this and they were looking for an answer, they would go with the primary square root, which would be positive 3, times negative 1 would be negative 3. So the square root of 361 is 19. So that would be plus or minus 19. Okay, because 361 is 19 times 19. Okay, if we continue on thinking about perfect squares, the square of an integer is a perfect square. So 1 squared is 1, 1 is a perfect square. 2 squared is 4, 4 is a perfect square. 3 squared is 9, 9 is a perfect square, as are 16, 25, 36, 49, 64, and on. So if we look along, not every number that we're going to try to take the square root of is a perfect square. So sometimes we want to sort of get a general idea of what the value of the square root is, especially if we're working without a calculator and or we want to try to put numbers in a certain type of order, understand what's bigger and what's smaller. So here I've got the square root of 3. Well, 3 is not a perfect square, but I know that the square of 1 is 1 and the square of 2 is 4, right? So those are perfect squares, and 3 is in between those two. So I know that the square root of 1 is equal to 1, and I know the square root of 4 is equal to 2. So I know the square root of 3 is somewhere between these, but closer to 2. So I'm going to say that that's approximately, let's say 1 3/4 or 1.75. I'm sorry, I shouldn't have been putting the square roots, the radical sign on. So it's going to be approximately 1.75, and then because we're multiplying it times -1, it's negative 1.75. Likewise, if we take a look at the square root of 150, I know that 144 is 12 squared, and that's close to 150, and I know that the square root of 169 is 13 squared. So the square root of 150 is going to be between 12 and 13, but a little closer to 12, so I'm going to say that it's approximately, and that's what this like squiggly equal sign means, is approximately. Let's say it's maybe 12.25 or something like that. Okay, so that's approximating the square root, and what I'm doing is I'm using perfect squares to get to create a bracket of values around the value I'm looking for, so to help me estimate its value. When we talk about numbers, numbers are made up in two big groups, right? So we tend to think of them as rational numbers and irrational numbers. This is within real numbers. In the terms of all number systems, we have two big divisions also between real numbers and imaginary numbers. In this course, we won't really be working with imaginary numbers. But when you look at the set of real numbers, it's broken into two big groups. There are rational numbers and irrational numbers. And a rational number is a number that can be written as a quotient of two integers, like 3/4 or 1/3, 1/2. Those are ratios of two integers. Irrational numbers are values that can't be written that way, and examples are square roots of things like the square root of 2, the square root of 3. Those are irrational numbers. The constant number pi is an irrational number. Euler's number, which is approximated at 2.71, it's an irrational number. Okay, but these are numbers that cannot be written as a quotient of two integers. Further in the rational numbers, we also have integers, right? Naturally, that makes sense. They must be there. If I can write rational numbers as the ratio of two integers, integers must be part of the real numbers. So integers are positive and negative integers, including the number 0. Then a subset of integers are whole numbers, which are just positive integers plus the number 0. And we're not elaborating on that in this particular graphic, but a subset of whole numbers are natural numbers, which are positive integers not including 0. So it's important to make sure you understand all these little subsets of different values, rational numbers, irrational numbers, and then within rational numbers, integers, whole numbers, natural numbers, etc. So let's take a look at how we classify different types of numbers. If we look at the number radical 24, well, 24 is not a perfect square, but it's definitely a real number. Okay, it is something that I could find a value for. Is it a rational number? No, it's not a rational number. It isn't going to simplify down to an integer. Is it, or as a ratio of two integers, is it an irrational number? Yes. Is it going to be an integer? No. Will it be a whole number? No. It's almost 5, really close to 5, so 4.89 or something like that. When we look at the square root of 100, the square root of 100 can be simplified to be 10. Is that a real number? Yes, it is. Is it a rational number? Yes, it is. If it's a rational number, then it's not an irrational number. Is it an integer? Yes, it is. And is it a whole number? Yeah, it is, because it's positive, right? It's a positive integer, so that helps make it a whole number. And when we look at the opposite of the square root of 81, that would be 9 times -1 is -9. Is it a real number? Yes, it is. Is it a rational number? Yes, it is. Is it an irrational number? No, it's not. Is it an integer? Yes, it's an integer. Is it a whole number? No, it's not, because whole numbers don't include negative integers. Okay, so you just want to be really solid on understanding what all these different things are, and that way you can help classify your different values. Okay, if we want to graph these on a number line and put them in order, let's go ahead and put 0 here. If I start looking at these different values, what's complicated is that some of these are decimals and some of them are not. So it's a little complicated. I know that 9, square root of 9 is 3, so I could go ahead and put that on here. 1, 2, 3. There's that. So that's the square root of 9. 2.9 is just under 3. It's right about here. So we'll put that there, 2.9. Then -3.7, 1, 2, 3, 4. It's a little over halfway between -3 and -4. So that's -3.7 is there. And when we look at -12, well, I know that this is also between -3 and -4. Right? The square root of 16 would be 4. The square root of 9 is 3. It's kind of halfway in between. If I want to actually get a little closer, though, maybe I want to go ahead and find out what that value is and make it a decimal as well. So it's just a little under 3.5. So when I put that on here, it's really close to this value. And that's the opposite of radical 12. Okay, but what's difficult when I have a mix of decimals and radicals is I need to try to put them all into the same format. So to help make this more clear, I went ahead and made it a decimal. A conditional statement that is not in if-then form can be rewritten to be in that form. So that if-then form means basically if this is a condition, then something else is true. So if we take a look at this, we want to rewrite this statement. No irrational numbers are whole numbers. Okay, so if I wanted to make this a conditional statement, then I could say that if a number is a whole number, then it is rational. Or I could say then it is not irrational, which would be more true to the original statement. I could also say if a number is irrational, then it is not a whole number. Right? These are converses of each other to some extent, but they're both hold true. Right? So this is how an if-then statement works. Okay, and that's it for us for section 2.1.